Okay, parallel and perpendicular lines.
Oh my gosh, you're such a
You should know a thing or two about parallel and perpendicular lines just from algebra, correct? What do you know about parallel lines from algebra? What's this, Kriya? Words. I need words. They what? They don't intersect. They never intersect. Okay? I also know that their slopes are exactly the same. What do you know about perpendicular lines? They intersect, they create what type of angles? The right angles, okay? So I know that their slopes are opposite reciprocals. Okay, parallel postulate, okay? And you don't have to necessarily write all of this down if you can comprehend what this is saying. It says, given a point not on a line, there exists only one line that passes through that point and is parallel to the first line. So if they give you a line, okay, and they give you a point somewhere that isn't on that line, then they're saying you can create another line through that is parallel to the original line. Okay? So given a point not on a line, there exists only one line that passes through that point and is parallel to the first line. So if P is not on A, then only one line B that passes through P is parallel to A. So if I have a point that is not on a given line, I can create a line that passes through that point that is parallel to the original line. Okay? Perpendicular postulate says, given a point not on a line, there exists only one line that passes through that point that is perpendicular to the first line. So you have line B, you have point P. I know there is exactly one line that passes through P that is perpendicular to line B. If P is not on B, then only one line, A, that passes through P is perpendicular to B. So I have the parallel postulate and the perpendicular postulate. Questions on those two postulates? Any questions on those two postulates? A lot of the stuff we're doing today is going to be, we're going to go through all the terms first, and then there's only like 2 examples really. Okay, 2 or 3 examples, pretty much because we're just going to learn a bunch of rules. Okay, corresponding angles postulate. Okay, corresponding angles postulate says this. If a transversal, which we're going to talk about in a second what a transversal is, intersects parallel lines, then all the corresponding angles and vertical angles, what's a vertical angle? They cross like this, my vertical angles are opposite of each other, right? Okay, so all the corresponding angles and vertical angles are congruent. So here's an example. These are 2 parallel lines. My transversal is simply a line that cuts through those. Okay? A line that cuts through those. Angle A and angle E are congruent. Okay? Angle B and angle F are congruent. C and G are congruent, and D and H are congruent. We're going to get separate rules explaining why each of those are congruent in just a second, including this alternate interior angles theorem. But corresponding angles postulate tells me that all corresponding angles and all vertical angles are congruent. Okay? All corresponding angles and all vertical angles are congruent when you have 2 parallel lines cut by a transversal. The alternate interior angles theorem, alternate interior angles, is exactly what it says. Angles that are alternate from each other. Okay? Alternate interior angles. If a transversal intersects parallel lines, then all of the pairs of alternate interior angles are congruent. So angle A and D are alternate interior. They're on the inside of the 2 parallel lines, hence the interior part, and they're alternate from each other. They're opposite like this. Okay? Alternate interior are congruent. So A and D are congruent, C and B are congruent. So if M is parallel to N, and it's cut by a transversal, then A and D are congruent, C and B are congruent. So we're getting lots of rules so that we can start to solve theorems, or start to do proofs easier. Carly's excited, I can tell Carly's excited. Okay, so corresponding angles says basically all corresponding angles, all vertical angles are congruent. Alternate interior tells me the insides of the parallel lines, when cut by a transversal, the opposite angles are congruent. Then you have the alternate exterior angles theorem, which is what it says. The angles on the outsides, okay, of the parallel lines cut by a transversal are congruent. So the last one was alternate interior, right? Interior angles. Now we're going to the outsides, alternate exterior. So A and D are congruent, C and B are congruent. Okay, they're on the outside, exterior. So if a transversal intersects parallel lines, then all the pairs of alternate exterior angles are congruent. Consecutive interior. Consecutive means what? What does the word consecutive make you think of? What? Sports. Okay, so what would be consecutive? What would that be? Winning in a row. Okay, so consecutive here is the same type of thing. It's going to be in a row. Okay? So consecutive interior angles theorem says if a transversal intersects parallel lines, then all pairs of consecutive interior angles are supplementary. What's supplementary mean?
It adds up to
180. Good. So here's the deal. So this adds up to 180. So here A and C add to 180, B and D add to 180. That makes my life a lot easier. Here's why. If I know one of those angles, I can solve for all four of them. Okay? If I know that A is 22, what does that make C? Yes, 78. If C is 78, what does that make B? What? 78, because of two things. They are alternate interior, which means they're equal, and also A and B, also A and B, right, are on a line, so they add to 180. Okay, C and D are on a line, they add to 180. So I can figure out all of these angles now because of alternate interior angles and because of consecutive interior angles. When consecutive interior angles happens, those two angles that are consecutive back to back add to be 180. Well, now I have equations going so that I can start to solve some things. Yay. Okay? Life becomes fun. Yes, lots of definitions. Here we go. Give me a second. I'll move this. Okay, skew lines. Skew lines are two lines that are not in the same plane and they will never touch. If they are skew lines, they're not in the same plane, they won't touch. They're not in the same plane and they won't touch. So skew lines are not in the same plane and they will never touch. So if I have, we're going to draw diagrams like this on your homework. If you have something that looks like this, okay, this is line A, line B, line C. What would be a pair of skew lines through there? No, A and B are in the same plane. C and A or C and B, they're not in the same plane, okay? When C is going vertically, they're not in this plane. They cross through that plane, they're not in that plane, okay? A and B are in that plane. A coplanar are lines that never intersect, okay? So planar lines never intersect. A transversal, I already mentioned that, a transversal is simply a line that intersects two other lines. Okay, and off of transversals, that's where we get alternate interior, alternate exterior, and consecutive angles. These three terms we just went over in the postulates. Alternate interior angles are, okay, alternate interior angles are inside a set of parallel lines, okay, on opposite sides of the transversal. Alternate exterior angles are outside the parallel lines on opposite sides of the transversal. And consecutive interior angles are angles on, okay, angles on the same side of the transversal. Yes,
Are these notes on Power School, like this?
They
Power
will be.
School? Okay, cool.
and between the lines, but all of these definitions are already typed up on Power School anyhow in the ones that have the chapters
Okay.
with the sections.
I went on chapter 3 and was looking at the notebook, but I couldn't open it or anything.
Okay, some people are having trouble with that, but not all people, and I think goes with your computer updating system. I'm not sure though, because I'm not techie like that. So you try that first and then let me know. Does that make sense? Okay. So we basically showed you alternate interior, alternate exterior, and consecutive all in those pictures, in those theorems. This is just to reiterate it in definition form. So like I said, lots of definitions today, yes? Lots of things to memorize. Go home and study tonight for 10 minutes definitions. Write them all out on note cards, or do whatever you need to do. Put them in a, what's that thing online? A Quizlet. Put them in a Quizlet. Okay? Do those things. Now we are going to practice a couple. We're gonna do 3 example problems, but I have to write them up, okay? Sorry, I just typed this up right before you guys came in because I realized when I typed up chapter 5 and 4 instead of 4. Okay, here we go. Here is a question. It says, a pair of corresponding angles created by a transversal and 2 lines have measures described by the expression 2x plus 3 and 3x minus 11. If x equals 14, okay, the lines must be what type of lines? Parallel, perpendicular, neither, or not planar, which means coplanar. Okay, so here's what we have to do. What do you think we have to do to solve this? Plug in 14. So I get 2 times 14 plus 3. What does that give me? 31. I get 3 times 14 minus 11. What does that give me? What did you say? Does it give me 31? Okay. So if they both equal 31, and the directions say, a pair of corresponding angles created by a transversal and 2 lines have the measures described by the expressions. If the lines, if you solve these, if the lines must be, are they parallel, perpendicular, neither parallel nor perpendicular, or are they not planar? Why, Carly? Why parallel?
They're the same.
Because they're the same, okay? Yes, the result is 31 in both of them. So the angles are congruent, and with congruent corresponding angles, the lines must be parallel. Okay, so they are parallel. Is that right? Okay, that looked weird to me for some reason. So they are parallel. Okay, 2 more problems. We're gonna do kind of like a proof. Okay. So here is a line that is a transversal. Here are 2 lines that are parallel. If you see this symbol, like this, a little triangle that goes through a line, that stands for parallel. That tells me those lines are parallel. Okay, so here's this Okay, I have this diagram, we're gonna pretend that it's beautiful. We know that this angle A equals 42 degrees. Okay, we have B here, C here, D. We have E, H, F, and G. They wanna know what is the measure of angle H. Okay, I wanna figure out what the measure of angle H is. How can I do that? If I know A is 42, that's probably going to be my starting point. What?
Subtract 42.
Why do you wanna subtract 42 from 180? Okay, so I have to state that before I can do it. Okay, we're gonna set up kind of like a proof. So, Kaden knows that the measure of angle A plus the measure of angle D equals 180 degrees because they are on a line. Okay, what?
Would we like write out the statement and the reason for this, like the two?
Okay, so because it doesn't say prove, you don't have to write out a proof on this one. You can just do the steps and do whatever. If it says prove, then you have to write out statements and reasons. If it says solve or what is, I can literally just substitute things in and not have to give reasons. Now in your book, they're going to give reasons so that they can back it up and explain things to you, okay? So we know A and D are supplementary, that's what they said for this. Okay, from there, I'm going to go ahead and plug 42 in for A, right? 42 degrees plus the measure of angle D equals 180 degrees. And that would have been substitution, right? So this is that they were supplementary, this is substitution. From there, you get the measure of angle D equals what? What is 180 minus 42?
$38.
138. 138 degrees, okay? That's just simplifying the problem. Okay, from there, what do you know? What?
The angle with D and angle H are, congruent
Why are they congruent?
because of the alternate interior angle
Yes.
theorem.
Yes, alternate interior angles here. So I know that the measure of angle D is congruent to the measure of angle H because of alternate interior angles. Okay, alternate interior angles theorem. So I can then say that the measure of angle H equals 138 degrees using substitution. Okay, do you see how these rules are going to help us solve things? Okay, makes it easy. So they are alternate interior angles, so I can go ahead and figure that out. Are they alternate interior angles? They're not alternate interior angles. This would be
Oh,
the inside. This is the outside because it's cut this way. Nope, not exterior. They're not both on the outside, are they?
Coplane. Consecutive.
Consecutive. They're consecutive.
And
angles.
mine was right above.
Okay. They are consecutive would be these two, H and C. They're not alternate exterior because that would be like this. They're not alternate interior because that would be like this. They're not consecutive because that would be this. What are they? Look at the first rule you wrote down. They're what, Carly? Corresponding angles. They're corresponding angles. They're corresponding angles, okay? Corresponding angles are like here and here. A and E are corresponding. B and F, C and G are all corresponding angles. So corresponding skips one, that's how I remember it, okay? Those are corresponding angles. Last thing, let's do this. Okay, I'm gonna draw another one up here. Go like this. Put these little triangles on here again, so that I know that they are parallel. And I'm going to label these A, B. And then this is C. D equals 35 degrees. E, F, G, H. And it wants to know what is the measure of angle E. Okay, what is the measure of angle E? That's what we want to know. How do I solve that? What do you know about this picture? What can we know automatically? D equals what? 35 degrees, okay. So we know that the measure of angle D, oops, I could write that would be great instead of my mind working faster. Okay, the measure of angle D equals 35 degrees, good. Okay. The measure of angle D equals 35 degrees. What else do we know?
The line AD is equal to line.
Okay, we can do it that way. We can do it that way. We also know, what else is D equal to? What? To what?
Or C is
D and, well, D and H are corresponding. D and G are alternate, exterior, so you're correct. D and G are, what? Is what B? Ah, you mean, are D and B equal? Yes, why are D and B equal? What? Vertical angles. Okay, so the measure of angle D equals the measure of angle B because of vertical angles. Okay? Because of that, this was basically argument. Because of that, I can say that the measure of angle B equals 35 degrees. From there, what can I do? How do B and E relate? They equal 180. Good, they equal 180. What's that called? What type of? Well, these aren't supplementary because they're not on the same line. They are one of the rules that we talked about. So I know that the measure of angle B plus the measure of angle E equals 180 degrees because they are consecutive interior angles. They are consecutive interior angles. Okay, consecutive interior angles. So then I can substitute 35 in for B, right? Then I subtract 35, and I get the measure of angle E equals what? What is 180 minus 35? What is 180 minus 60? Not 165. 145. So the measure of angle E is 145, I simplify. Okay. You have to get familiar with these. My suggestion to you is this. Have your notes out when you're doing all this homework. Make sure that you have the pictures drawn on your notes. The pictures are what's going to help you, right? You'll understand the rule if you understand the picture. Does that make sense? Okay. This is what we are working on tonight. So there are a lot of pictures on your homework.
note cards to write down.
Definitely.